Hello everyone. This week we are going to be covering the lab of the synthesis of the benzoin. This synthesis is called benzoin condensation and is done by reacting the benzoin by itself with a reagent that we're going to be seeing later, and then it's going to auto condensate and then get the benzoin molecule as it is shown in this scheme over here. You can find more information about this synthesis in the chapter 48 of the textbook. So this synthesis normally use the cyanide ion, which is this one over here, as a catalyst for this reaction. But the big issue with this ion is that it is a very strong poison for our blood, so it can cause death to the living things, and then we are gonna try to avoid this reagent in this lab. To substitute this reagent, we're gonna be using vitamin B1, which you know that this is a very easy compound that it is not toxic for us, so we can use it very well. But how are we gonna use the vitamin 1 in this case? This is the formula of the vitamin 1, the one that you don't need to memorize, but you have it here anyways. And then this vitamin 1 under basic conditions is gonna go under deprotonation, then get this carbon ion, which is also a base. This whole monster add as a base, replacing the cyanide molecule that you have that you need for the benzoin condensation. We're gonna treat it like that. So in this case, they just summarize the molecule by replacing this part of the molecule by R1 and this part of the molecule by R2. This way you can easily understand the mechanisms and then work easier for the scheme of the reaction, etc. So let's go to the mechanisms of this reaction. The first step is going to be by the base attacking the carbonic group of the benzaldehyde and then making this tetrahedro intermediate, which is going to absorb one proton from the water, and then it's going to get this alcohol derivative. Then after that, another molecule of the OH that we're going to have in the media is going to grab this proton from the previous intermediate, and then you're going to form this carbon ion, which is in tautomeric equilibrium between this and this with a double bond, and they are resonant structures. And then after that, this carbon ion is going to attack another molecule, the other molecule of the benzaldehyde that we're going to be using, and then get this intermediate, again tetrahedro. And after that, this it's going to be a transposition from the hydrogens. Then this oxygen is going to grab this hydrogen from this OH. Then in this process, they are going to eliminate the catalyst that we were using. So at the end, we're going to regenerate the catalyst as it is, and then it's going to leave us only the benzoin as the important organic part, which is this molecule over here. So for the procedure, we're going to use the thiamine hydrochloride. We're going to use around 1.04 grams. Then we're going to add 3 ml of water. We need to make sure that this is completely dissolved before keeping going. And then we're going to add 8 ml of ethanol, 90%. This is also the solvent of this reaction. Water plus ethanol, they are the solvent. You need to be aware of that. Then we're going to add 3 ml of aqueous sodium hydroxide solution. Remember, this sodium hydroxide solution was going to help to deprotonate the thiamine hydrochloride to make the base for the condensation. And then we're going to add the 3 ml of benzaldehyde, which is our reagent, our main reagent of the on the experiment. If you remember correctly, there is a here, see upcoming slide, and possible need to purify the benzaldehyde. The first lab that we did in this class was the purification of the benzaldehyde, so we don't need to see this again. We already saw this in the it was in the second section when we see the purification of the benzaldehyde, which was a very easy experiment. After that, you're gonna mix thoroughly after each addition, and you're gonna be stirring very well. Keep at room temperature for overnight. So this reaction is actually very easy because it you just mix everything, mix it with your hands, and then just keep the reaction going, not overnight, because you never have a lab from one day to another. You just leave the reaction for 1 week actually. So the reaction is done in 7 days by far. You will complete the synthesis of the benzoin in the next class meeting. So in the next class you're gonna do the workup of this reaction and then finish it, and then isolate the benzoin as the molecule. So the part of the benzoin isolation, first you should have fine crystals in the beaker, and then you're gonna use a small Bochner funnel, which is this one over here, with a filter paper to get all the solid that you have precipitated. You don't need the solution in this case. You should just filter it and then isolate the solid that you have. They put you here a comparison, so you don't use the RAM funnel. This is not used for this experiment. You need to use the Bochner one. So there is a chance that the benzoin didn't crystallize during the 7 days or during overnight, and in that case you can do some operations to help with the crystallization. First, the first one that you can do is place your flask in an ice bath. If you decrease the temperature in a dissolution, it can help with the crystallization of the solid that you have dissolved in the into the solvent. So this is an operation that you can do to facilitate the crystallization. Also, you can do the gentle scratch of the inside of the flask with the glass rod. It's actually a very used method that you see commonly used to precipitate materials. You can do it as well. And the third one is that you can place a teeny tiny crystal of the benzoin into your flask and swirl and cool. So this is only done in case you need to crystallize something, in case that you didn't crystallize anything during the week, which is actually very weird happening, but it can happen sometimes. The TA is gonna provide the crystal of benzoin that we have. So after the filtration, you're gonna wash your product with a small amount of cold ethanol and water. So a mixture of 50% of ethanol and water. Benzoin will dissolve in ethanol, but it's much less soluble in water. So that's why we are using a mixture of ethanol and water, because if you use pure ethanol to wash, then the benzoin is gonna dissolve. But by mixing with water, we decrease the solubility, and then we can wash it with the mixture of ethanol and water 50%. Then you're gonna dry the compound, and then you're gonna get the weight in the balance, and then you're gonna calculate the yield from that. In this case, we don't need to purify the benzoin, because for the synthesis of the hexaphenyl benzene, which is the last product, it is not need the purification of this one. So you just leave it like that, and it's gonna be fine. So the spectroscopy is gonna be pretty much similar. We're gonna dissolve our material in chloroform for in the case of the NMR experiment, and then we're gonna get the NMR. Then we're gonna analyze it, and then get the corresponding peaks for this material, And then for the IR, you're gonna use the solid itself, and then we are gonna go to the machine and then use the solid to get the IR spectrum. In this case, you have already worked a lot of time with sodium hydroxide solution, so you know by this step that sodium hydroxide is a corrosive reagent and it can cause some burns in the skin. So you need to be careful. Always wear gloves by handling this reagent, and just be careful that don't spill in the fume hood. And if you do, you need to be careful and you need to clean that very quickly. Otherwise, it can cause some accidents to them, to your partner or yourself. Benzaldehyde, we already covered this in the benzaldehyde purification lab, but I'm gonna go through it very quickly. As you may remember, benzaldehyde is easily oxidized to benzoic acid by air, so we need to purify it before using it. We may choose a new bottle of benzaldehyde that should not be contaminated with the acid. However, if we are not confident of the benzaldehyde, we may have to perform an extraction to purify the benzaldehyde. We already did this in the first lab, so you are using in this experiment a purified benzaldehyde that you did already in the first experiment that you did in the whole semester. So this is the page anyways that you can find the purification of this material in case you need to check something. That's gonna be for this week. Have a good one. Bye.